So we can look at an even simpler example to get the basic idea. If we have a file, a C file that defines f and expects a v somewhere and just refers to it directly. If you use GCC with -fpic and then -shared to turn this C file into a shared object, you'll get an elf file that looks something like this. There will be a text section. And where we wanted to look up v here, we wanted to put v into the register RAX, we will actually look into a different place. This is like the data section, but it has a special name where there's a VP kind of variable. And that VP variable is initially 0, but that can be filled in dynamically. Meanwhile, text refers to that address, and so it gets the address of v into RAX, and then following an indirection, right? It's really sort of the address of VP. Putting star in front of VP lets us get the actual return address. Meanwhile, there's a rela.dyn section that tells us this tells the dynamic linker. This is the address when it corresponds to a variable like VP that you need to fill it in with the address of the actual V wherever it comes from at runtime. This particular reference from the text segment to the GOT stands for global offset table, right? That can be a relative reference. So it turns out that these addresses that are picked for the text segment and the offset table segment, these addresses are going to be kept in sync when we actually load the code. When a shared library is loaded, it might not be that we can put it at exactly the predicted address. We might have to relocate the code. That's okay as long as we also move the global offset by the same amount to keep them in sync. And then this purple arrow turns out to be implemented with a instruction pointer relative lookup. We talked earlier about how move can't directly access the instruction pointer. That's why we need things like jump and branch instructions. But it turns out there's one specific pattern where you can refer to the instruction pointer with move, and that pattern is the one that has the shape where you're looking at the instruction pointer plus some fixed offset. Can be 1 byte, can be 4 bytes offset, and then move that into another register. So this purple arrow here is actually this pattern right here. And that's why as long as we keep text and the global offset table together, maybe when we load it into memory, it's at hex 8000. As long as the global offset table is still 200 away from that, then this relative reference will work the right way. Right. Meanwhile, rela.dyn, that's telling the dynamic linker how to patch that particular place with the address of the variable v.